everybody. Welcome to my kitchen. This is Miss Amy with the Memphis Public Libraries, and today I'm going to be performing some science experiments with candy. So I went crazy after Easter and bought up a lot of candy that was on sale. And so today we're going to test some of the candy bars from this assortment pack to see if they sink or float. So let's start off with a Nestle Crunch bar. Let's drop it in the water. Look, it floats. All right, next up is the Twix bar. So let's drop it in, see what happens. It sank like a rock. Let's try a Snickers. It sank. Let's try Three Musketeers. It floats. All right, up next is the Milky Way. It sank. And last is a Kit Kat. So let's drop it in. It floats. Yay! So now we're going to separate these out. So this is a floating candy bar, and these, the Kit Kat, and then the Three Musketeers. All those floated. And so now we're going to put our Twix over here, our Milky Way, and our Snickers because those sank. Now, why did some of the candy bars sink and some float? Well, certain candy bars are light because they're full of air bubbles, and the air bubbles make the candy bars less dense than water. Thus, they float. Now, we're going to test one candy bar from each side. And we're going to start on this side with the candy bars that sank. I'm going to take the Twix bar. Can we make this Twix bar float? Let's give it a try. So I'm going to take some soda and we're going to fish it out of the water. And I will drop it in the soda. Let's see what happens. Wow, it's magic. It's not magic, it's science. But look, now it's floating. Why? Well, soda contains carbon dioxide gas, and as bubbles form on the candy, they help lift it up, making the candy bar float in the soda. It's like a bubble life jacket. Now I use Sprite for this. The soda, as you know, contains sugar, making it denser than water. And this is why some candy floats better in regular soda versus diet soda. All right, so let's set this aside. And now we're going to try a candy bar from the float side. So I'm going to take my cup of oil and I'm going to try the Crunch bar and fish it out, and let's see. Will it sink? Oh yes, it sank. Well, why did it sink? Well, these candy bars floated in the water because they were less dense than the water. Think of all those trapped air bubbles. But oil weighs less than water, making it less dense. It's also less dense than the candy bar. So the candy bar sink in oil. Wow. What fun. Now, boys and girls, we're going to have some science fun with two of my favorite candies, M&M's and Skittles. So first off, I want you to look at my bowl here. I have placed yellow M&M's and red M&Ms in the bowl. Red and yellow make orange, or do they? Let's try and add some water to the bowl and see what happens. All right, now let's look at the second bowl that I have here. You'll notice, let me pick one up so you can clearly see what letter is on top of the candy. You're right, it's a lowercase m. So we're going to place these M&Ms face up in the bowl, and we're going to add some water, and then we're going to see in a few minutes what happens with this bowl. All right. Now I'm going to set this bowl aside, and we are going to look at our other bowl. What is happening, boys and girls? You're right, it did not combine. We see yellow and red. Well, let's try Skittles. Let's see what happens when we pour water on Skittles. So I have placed Skittles in a pattern on the plate, and I'm going to pour some water, and let's see what happens to Skittles. When you put the candy in water, look, the colored sugar in the candy coating starts to dissolve. The dense sugar water sinks, forming a puddle of color on the bottom and pushing the less dense water out of the way. As the candy dissolves, the puddle spreads further. Because the puddle spreads so quickly, you might think that when the two puddles meet, they'll mix right together. But they don't. This is because the two puddles have a similar density, so one can push the other out of the way. Instead, the puddles spread sideways, pushing aside clear water until the two puddles seem to have met completely. So, do they ever mix? Water molecules are always moving, and eventually this movement will cause the colors to blur and mix together. If you want to speed up the process, just give it a good little stir. Now, let's check back on our other bowl and see what's happened to our M&Ms. What do you notice, boys and girls? What is floating at the top, on top of the water? Our letter M's. So the white letters on the M&Ms are printed in edible ink that doesn't dissolve in water. So when the rest of the candy shell dissolves, the letters peel off and float. Finally, I saved the best experiment for last. We've got a Diet Coke here and a tube full of Mentos, and we're gonna see what happens.
Whoa, a soda geyser!
So what just happened? We had a great reaction. To start, it's not just Diet Coke and Mentos that react. Other carbonated beverages will also readily respond to the addition of Mentos. What's going on here is that Mentos has thousands of small pores on its surface. This porous surface creates a lot of bubble growth sites, allowing the carbon dioxide bubbles to rapidly form on the surface of the Mentos. The buoyancy of the bubbles and their growth in size will quickly cause the bubbles to rise to the surface of the soda. and bubbles will continue to form on the porous surface, and the process will repeat, creating a nice foamy result. But make sure that you use mint Mentos, because the other Mentos has a waxy coating and you won't get as good of a reaction. Thanks for watching.